everyone, welcome back to Data Leaps. Today we are starting a new series called Databricks and Friends. And the first guest on the series is Toon from Anomalo. Welcome, Toon. Do you want to introduce yourself?
Hey everybody, I'm based in Holland, working for EMEA customers. Joined Anomal about 7, 8 months ago, and having fun here. It's a fast-paced, small but growing startup. And one of the most important things I think, which made me like my job, is our great partnerships. So Databricks is definitely one of our biggest, maybe the biggest friend we have. And I'm very eager to show you guys a bit more about how it works and what we can mean for each other.
Anomalo is a data quality partner of Databricks. Within Databricks, we have different features within different product families to manage data quality across the platform. But you do need to know what these features are, and you need to put them together yourself for a consistent and holistic data quality management solution. Whereas Anomalo gives you a managed solution to work with. So yeah, Toon, do you want to just introduce a little bit more about Anomalo and how it integrates with Databricks, how it can help data practitioners to better control data quality on their Databricks Lakehouse?
Yes, definitely. I think it's a great question you're asking because it really comes up from the start. Why do we need an external, or in this case, maybe a semi-internal partner? Because Databricks did invest in us. I have a small slide that I would like to show you. This is really a technical slide. I'll go over that, and then afterwards I will also talk about what are the implications, from the more, I would say, customer or user perspective, besides just which features you have. So first of all, yeah, you do have multiple things already in the platform, and I think that number of things is growing, which is good. So there's most of all the live tables, which have features that are you call expectations. They're basically rules, right? You define certain conditions which have to be true. That's a very useful strategy, we think as well, but it only applies, and I'll show this later in tool in our demo. It only applies to a rather small, it should only have a smaller role, we think. There is definitely a room for rules and for expectations, as you call them. But they are not, let's say, if you only base your strategy on rules, we've seen from our own history, it's going to be very hard to scale, right? The difference between anomalous rules and your expectations is that the persona that you can cater to is different. In the case of Databricks, it's really the technical users, people that like to use code, people that are happy with code, SQL, Python, etc. That's perfect. And if that's the way, that's the thing you're doing now in Delta Live Tables, yeah, great. Go ahead. We agree that that's a great strategy. However, we have many more things which I will list afterwards, including catering to not that technical users, people with business intelligence experience and knowledge, people that understand their data. They know what should be happening with the data, what should not be happening with the data, but they might not necessarily know or be very comfortable with SQL or Python or any other code-based approach. That's one thing. The other side of the spectrum is lakehouse monitoring, which is actually more, as I understand, more of an offshoot of model monitoring, right? So the approach taken for lakehouse monitoring for models makes a lot of sense, right? You have baselines which correspond typically to your training data of your model or your testing data of your model. And it's really important for people that do data science to be able to ascertain whether or not the data that is being driven through these models, that are being pushed through these models, the inference data in the real world, after models have been created, whether that data still agrees with enough with the training or test data. Because if not, you have to retrain. That's just, models always become stale. In a previous job, previous life, I worked a little bit on this as well, so I'm very familiar with that world. It's super cool, very useful, and it makes the operationalization of these models much more feasible. It's not an easy job to do. Um, However, we think that for data quality, not just model quality, but data quality specifically, it is again only a limited approach. It has its uses for sure, but for fully comprehensive data quality monitoring or like suite, we think there is many more things. And that's why we think it's only a limit. And we would love to speak to you today about how you can extend what you do with both Lakehouse monitoring and Delta Live tables, and see how with our tool and our easy integrations, how we can actually bring more people into the game, people with different skill sets, people with different interests, how you can broaden use case. And the end goal is also, of course, good data. Why is good data important for Databricks? Databricks is a full, like, comprehensive platform, and it's really fun to use. And the more I see you guys going into like building stuff on top of data, not just the querying and the warehousing and the Spark execution, though that might be interesting. Like, the more I hear about you guys going into creating things on top, like models and deployments and apps and graphical interfaces and shareable assets, etc., that's where I really get excited, because that's where you see there's going to be an economy of scale that's going to take off. And to do that, you do need quality, right? If you don't have your quality, you can build on top of it, or you can build and nobody will be, comfortable using it. So we think that by giving organizations, your users, ways for making data quality much more of a doable thing, will open up the way for way more usage of the more, I would say, fun parts of Databricks.
It's really interesting. A few points you mentioned, right? So Delta Live Table is more rule setting and taking actions based on violations of rules, and the Lakehouse monitoring is more statistical summary of certain metrics and the drift of those metrics. To your point, it's an extension of model performance monitoring. I'd be really keen to see how these two different experiences, both are very important for data quality management, and how Anomalou can have a consistent and comprehensive data quality management experience for the end users. Another thing you mentioned is really important. Delta Live Tables offers declarative pipelines for SQL and Python, but certainly certain business rules, semantic rules coming from the stakeholders within the business don't speak Python or SQL. And if the communication and collaboration is not fully set up and fully functional, some of these requirements can get lost between the engineering team and the business stakeholders. So I'm very keen to see how you can set data quality rules without having to code everything. And absolutely, like your point is absolutely valid on data quality is more and more important. The more use cases that we build, we go from the engineering to machine learning to Gen AI. None of the applications you build on top of data is meaningful or useful if it's not built on the foundation of good quality data. So yeah, very keen to see a demo and see how Anomalou can enhance the data quality experience of data practitioners in Databricks.
Great. Yeah, and we do see a lot of common interests, right? So I'm very keen to explain this more in detail. I'm going to close this. I have a few more slides just to highlight it, but I'll spend most of the time in tool. No worries. I just want to give us like a frame we can reference afterwards. So data quality is hard. We don't have to go in detail here. Like, people spend way too much time fixing stuff. I think many Databricks data engineers probably would like to spend less time fixing things. That's a common complaint. But again, like you just mentioned, in general, data quality is important because that's the foundation. Now, why is it hard? Well, there is multiple strategies. We think this is a great way of representing reality, and that is basically that you start with nothing. That's like a new company, how it starts working, our new organization. You start writing rules because that's a very common way of doing things. However, you will realize you have to start rewriting rules because they might not be exactly what they need to be, or because the world has changed, right? Maybe you have no, maybe if you're a retailer, you have a new store opening somewhere, so you have to rewrite the rules because there's another option which wasn't available before. And the big problem with this is, and this is also why we think that expectations have their use, but there's only a part of the picture. The big problem is you can really get stuck quickly and disastrously into what we call like a little bit I would say theatrically, the doom loop, right? So you just spend all your time creating rules, rewriting rules, and then in the end, you might end up in nothing again. It's if you have the situation happening, it's not your fault. It's just we think it's just the wrong approach for the current age. We have so much data; it's so hard to write rules that cover everything. And later we'll also see that even if you have rules which cover everything, it's so hard to keep scaling and it's so hard to also use them because you will get so many alerts and you will be so fatigued by them that it will be hard to act on them, right? So actionable data quality requires more. Scalability requires automation. I think we can all agree on this. So to break through the doom loop and to get to this automatic data quality part, which allows you to really scale after all and create these applications on top of them, all within Databricks, that requires you to go and break the loop. So what we do is we have an approach we think is really valuable and our customers agree that allows you to avoid as much as possible having to create these rules. And we use machine learning techniques to do this. And the cool thing is, rather than degrading with time, because rules, become stale, have to be updated, and people have to do that, these techniques based on machine learning almost automatically become better with time because the machine learning algorithms we use learn more the longer they are in operation, right? So it's a different approach. It's much more geared towards scalability. We have three axes we should talk about. One is going to be detect. How can we detect things with machine learning? Like it's not just rules, it's many more approaches. We'll talk about that at length. But also it's important to realize there's two more axes or dimensions or elements you have to make sure you have in place to make sure it works, right? It's actionable. First of all, making sure the people get alerted the right way. There's many people involved, many personas involved, and they all have their own way in which they would like to consume data quality. I'll get into that into more detail afterwards. But basically, you can imagine a person creating a large language model or another AI data science model would probably prefer to be alerted when something's wrong, whereas a business user with BI tools would probably like something like on top of the dashboards, etc. There's many things, and then there's also people that are responsible for the quality. They will probably require much more in detail knowledge. Of course, things do go wrong, which is why you also need to have an efficient way of resolving things. So this is not just being able to, create a ticket in Jira or something, but it really goes down also to into the elements of can I actually see where data quality problems come from? And in the demo, I'll cover all three. Now, final slide, I think. This is to situate our tool and within the modern data stack, which is basically data coming in from places, being collected in Databricks and other data warehouses, data lake houses, data lakes, etc. There's many different options. But basically, the real goal of this is that you can then create end applications like BI tools, dashboards, and or machine learning and other data science applications. Like nowadays, you're starting to see lots of large language models and other Gen A applications. There's also some orchestration that's running, like pipelines, some transformations, some other operations running on your data. And the problem is that in many places things can go wrong. You can see a few examples of what happens at the ingestion time, right? Missing data, late data, schema changes. Somebody upstream said, well, let me just write this field in a different format now. Duplicate data, API changes, missing feeds, all of the problems can happen. When you do your orchestration, many more things can be going wrong there, like bugs, failed jobs, missing data again. And all of this in the end leads to bad stuff for the end user. These people, the end users, are really the ones that really have most to gain with good data quality because they will be able to build their tools or their solutions better. Right, so we live here on the left-hand side, which means straight next to Databricks. We're often installed or deployed straight in the same VPC or whatever it's called in other cloud providers. And we're often really tightly connected to Databricks, which means you can really reap the benefits of both systems really nicely. And I'll show you in a second what it looks like. First, or final slide, sorry, the real final slide is what we will show is again the monitoring, the finding errors. We'll use machine learning. We'll be able to get about 80% of the coverage our customers tell us. using automated methods based on machine learning, etc. But also we'll spend some time on these validation rules, which we still think that are valuable, but they're only there to get like the remaining 20%, and we should be able to do that in the right way. And then we'll talk about some root cause analysis, which was for resolution of things. And then I'll jump into a demo now. This is just a quote I was asked to show about one of our users from Discover, which is a financial institution in the US. And they basically, the only thing I really want to show, I don't want to brag too much, I don't like it, but the only thing I really want to show is this here, 25 years of people, basically a person has to sit down for 25 years just to get to the same level of data quality, you writing rules, right? This is obviously very unscalable because by the time 25 years are over, who knows how the world looks like, right? So it's really important to scale using automation.
I hope to
Any
be
questions?
retired by then.
I hope to be
So
retired by then.
right, cool.
Or
So
engineer.
you show some very interesting screenshots of some very slick looking UI. So should we go into a
Yeah.
demo and see how Anomalous works?
Yeah, let's do that. I'm already showing here that my first in tool screen is not going to be my tool, Anomalous, but your tool, Databricks, right?
Yeah,
Just to show you
familiar.
that we actually, one of the reasons we play well together is that often people go to Databricks, you know, in your case, people go to Databricks to get their data quality, to get their data. It's also nice if they get their data quality with the data, right? So in this case, I search for transactions. I've got a few tables. This one seems to be used quite a lot, 14,000 queries in the last month. It's nice that you can see that this one is monitored by Anomalous. And actually, if I open this up, you'll see it gives you an indication of the quality of this table, right? In this case, it's a demo table, so expect some drama, but 3 types of checks have failed, whereas 3 have passed. This, to me, as an end user, I might be a AI data scientist or somebody creating models. I might be worried by this, and I probably should talk to Mr. Anthony here, and he should have a look at the data quality. This is a very
Absolutely.
common pattern. Yeah. People consume data, and they also should be able to consume the quality with the data.
That's really cool. A lot of the customers we work with, the first question that the data consumer asks is, can I trust this data? Do I trust who produced the data, wrote the right logic, and the quality of this data is good? The fact that you integrate with Unity Catalog and the metadata of the table actually shows the data quality checks and passes and fails is a good way to tell the end consumers how much can you trust this data, and if there are issues with this data, is this rule relevant to you? Can you use it regardless of the certain type of checks failed? So yeah, that's really cool.
Yeah, thanks. Yeah, great. And indeed, and I could now go into Anomalous and start checking what's wrong, right? But before I do that, some other ways in which people actually consume data is often through things like, a Teams notification, a Slack notification. And I'm mentioning this explicitly because this broadens up. This is what we see when people use Databricks and Anomalous. They start seeing people becoming interested that are not typically your typical Databricks users, right? There may be people that actually are the end consumers of a dashboard, right? So they have teams which work and create a dashboard, but they don't really know too much about what's going on. If they get an insight into the quality, like you just said, then they can also make sure that there is more responsibility, right? There's a whole concept of data contracts. It's all philosophy, but these kind of things fit well within that philosophy, right? People should know when what they use is trustworthy, and if not, there should be responsibility. So being able to see what's going on is super important, and we have that as well on the platform, so we can broaden it to other personas for you.
I'm
Yeah.
assuming it's webhooks, so you can hook it up to Teams, Slack, any kind of communication tool that you're using, right?
Yeah, it's based on webhooks. Yeah, right.
Cool.
One thing I should also show you is right here, the integration with orchestration frameworks, right? Workflows, for example, being able
Yes.
to use data quality I'm going to make it a little bit smaller, sorry. Being able to use data quality within your pipelines, within your existing transformations, automatically through code, through the API is also a common use case we see. This is a bit of a sketchy, like a sketched use case. You probably have more blocks, but really being able to run the checks and then check the check results, and based on the actions there, either continue with your ETL or do something else like quarantining data or whatever, right? That's also a common workflow we see, increasing data quality overall.
Right. So Anomalous detects the invalid or inaccurate data, and with workflows, you can pass it back to Databricks to actually handle or do the cleansing of those data quality issues, I suppose.
Yeah. Yeah, we believe it should be responsibility of people that create these data sources and pipelines to fix things. In our case, we only read the data. We only are able to deduce quality, but it's really pass the ball back over to you and to your users to fix things, yeah, and take action.
You know, the
Yeah.
table metadata that you were showing with the checks passed and failed, is that automatically done, or do you have to add an additional step for Anomalous to write
No,
back to the...
this is the current integration. So you can see there is
Ah,
a tag
lovely.
monitor by Anomalous, and we populate the script. And I hope one day we'll have a more integrated UI experience, but this is the current way it works.
Cool.
I'll go into Anomalous now, and yeah, you'll see that you can also like basically the information from UC from Unity Catalog ends up in Anomalous as well. So we can do things with the metadata from UC as well. So this is Anomalous. I'm jumping straight into a data quality issue, right? I'll zoom back out afterwards, but here you see something happened on the 5th, on today, basically yesterday. And we found a few anomalous records. So this check called no anomalous records failed. We've got a few problems here, 4 basically. First of all, we see like there is a severe issue which we found. And it actually says, well, it looks like we have a very big drop in a certain column which contained a lot of fast food records. This is a transactional table, so every day we have new records being added. But today we suddenly only have 0% fast food, and yesterday we had many more, 14%, right? At the same time, we do see that food actually has grown by 12.9%, and some other small things have changed. This is probably a problem because to me as a user, it directly tells me, well, maybe somebody changed the way they log different food transactions and everything became food and they might have forgot to communicate this, right? So this information in a visual way is what we provide to our users, right? It could be an issue, it could be not an issue, but it's at least you can see what's going on. And the cool thing is behind the scenes, this doesn't really rely on rules at all. We check patterns in data today in a more abstract sense. We check the patterns, what's there, different distributions, and we compare with the past, and not just yesterday, but many more days into the past. There is different strategies here. And whenever something is out of the ordinary, we do surface this. So it's up to the user, of course, to say whether or not this is really an issue. But if you don't have these insights, it would have been very rare that you just by chance happen to have created a rule which checks for decreases in fast food, right, in your data. So machine learning helps you get the unknown unknowns. Yeah.
And how is the severity kind of determined?
Yeah, that's also a good question. Behind the scenes, SHAP values, et cetera, et cetera. But basically, it's a calibration step. You can imagine. We calibrate how anomalous some things are, and it ties into also the aspect of alert and alert fatigue. If something is not very severe, we should not tell you, even though it might be interesting, so we can give you insights into it, but we'll not wake you up in the middle of the night. But it's a calibration step. We learn over time. This is really a machine learning based check. So the first few weeks, if you start monitoring new table, we actually have a very high threshold. This number here will be very high. This bar will be very high, and we don't alert you at all. But after a while, we get more and more comfortable with the data, and we start seeing things happening, and we're able to give you a much more finely tuned severity score.
Interesting. And could you scroll to the right a tiny bit. It says today, and the other one is
Comparison date.
comparison date. Right. Okay.
Yeah, I
Makes
can
sense.
compare
Yeah.
to other days. Today, it seems like we only picked up something compared to yesterday.
Mhm.
But we often have the case when maybe something yesterday was different, but last week it was the same, so it's not an issue. So we do multiple comparisons.
Interesting.
Actually, if you want to know more about the details, it's pretty hard to create such systems in detail because you can think about situations where you've got historical updates. Today, like imagine last week I had a certain distribution of my column values. But maybe today when I query historically, it's already changed because things were overwritten. So you got to make sure you keep all these things into account, like not just the historical values, the snapshots from back then, but also current like live queries from last week. So that's all taken into account. And if that is an issue, or sorry, if that's a factor of importance, it will also be shown here.
Cool.
Yeah.
Interesting.
Yeah, and there are more things that users actually get access to. First of all, I didn't have to write any SQL. That's a time saver. I do get graphical information, which is nice for people that know the data well. Often they like to see things in graphics, not numbers. But I could of course also get some information in a more, let's say, traditional sense. So we do surface some of the sample data, which gives you an idea about how bad or anomalous records behave and how non-anomalous records also behave. More useful, perhaps, however, is if I go to the next anomaly here, and let's not focus too much on the anomaly itself, but if I go down, you see there is a root cause analysis. The first one doesn't have it because if we don't find any root cause, we don't surface it. But in the second anomaly, we actually found a root cause. So we do a lot of comparisons and we statistically compare different column values with the anomaly. And we surface what we think are the bigger possible explainers for why you have this anomaly. So in this case, if I were the owner of this table, I would probably know I have to look at Lyft and Uber because they seem to be very highly correlated with bad data. Do you have any experience, Lipping, with like fixing errors, and do you know how it typically goes, or do your customers have this kind of task sometimes?
I think it's relatively manual most of the time when the bad record happens, they get alerts and they go manually fix it. I haven't seen a lot of root cause analysis on what's driving the bad record. So that's really interesting to look at, definitely. Yeah.
Cool. Yeah, it helps. Helps. Some of our customers say that they have, like the technical folks, they save half their time not having to sift through lots of data.
It could be like a particular source or a particular table that's generating the bad data. So, if they keep showing up in the root cause analysis and you go fix that source, that will fix it longer term rather than always reacting to the issue on the spot. So yeah, makes sense.
Yeah, you're right. Yeah, it often indicates a segment which is populated by some upstream process which might be broken. Maybe my new store in London certainly has a broken internet connection and doesn't send any data over. That happens, right? So this would capture that, and we've got some other checks that would also capture this. But you're right. It's all about making sure it's actionable and then that you can fix it before it happens again. Not reactive, but trying to be as proactive as possible.
Interesting.
Cool. That was a check example, right? If we go to so if I click here on my table itself, you'll see this is the view of the same table, and it shows all the other checks as well. The one we just spoke about was right here, but you can see there are other checks as well. When you set up a new table, the only thing we need to know from you is whether or not there is a time a time column, which means, you probably are talking about a transactional table where things are added every day, et cetera, et cetera. We can definitely handle transactions table like dimensional tables, which are basically rather constant in time and which do not have a time column. But it's often these giant transactions tables which are hard to monitor, especially just using rules. And that's why we really focus on these to bring the most value for our customers. So if you have a time column, great, then we can do many more smart things like incremental analysis. We only check for the new rows in most cases, some smart sampling strategies, some smart gating strategies. So we really take into account to the efficient usage of the data warehouse, right? So that's why we love working with Databricks, because there is a lot of things you can tweak in Databricks as well to make sure that when you query these tables, it's being done efficiently.
Yeah. I mean, at the bottom of the screen, you had data freshness. I'd imagine that's in relation to like timeliness of the data quality dimensions. And if you have a time partitioned table, it's relatively easy to spot if, the data has been up to date, compared to a dimension table that without, let's say, SCD2, you probably it is a little bit more difficult to say, is this dimension table like updated today or
Yeah,
recently? Yeah.
precisely. It's really to make sure that these hard to monitor tables or monitorable and time information is crucial. But as you can see, we've got two types of data quality. One is the what we call table observability.
Mm.
These checks check for, is my data schema unchanged? Does my table exist? Is the expected size the way I expected, et cetera, et cetera. And these are just metadata checks. So they take the UC information. They don't really query the table itself. They're cheap, therefore, and they run fast, and we run them often, right? So you can expect this to bring some kind of a broad baseline quality result to the table.
Mm.
The interesting, in my point of view as a data scientist, the interesting stuff, however, happens with data quality, which is where we do query data from your tables. We do create machine learning models. We use some strategies like this. And this is where you can get much, much more coverage for your data quality. We always say that everything you see in the screen, including the table observability above, brings you to about 80% of data quality. This is like a rough estimation. And to go to 100, you will start having to use your domain knowledge. And I'll speak about that as well in a second. Right. But so far, everything is really automatic, right? We spoke
Right.
about no anomalous records. I've shown that. But there's a few other things which might be relevant to your listeners or your watchers, viewers. I'm not sure what the right word is. The first
It's
one
all
here,
right.
freshness. The freshness
Mhm.
thing is, like you said, like when does my data arrive? And again, we give like we give
Oh,
visualizations.
nice. That's a very
Yeah,
nice looking graph. Oh, wow.
you can see patterns, and this is really more about, are there historical updates? It's not the most flashy check, I would say, but it's really useful because often you get like you. I can explain how to read this graph, but often you have changes happening over time. And if you have this consistently, this is actually pretty bad here. You don't want to have up and down, up and down, up and down. You want to have like tables updated and it stays constant after a while. Right, so this information is there for you. Data volume, however, is the one I wanted to open as well, because it gives you an idea about how time series information is being used. Make my screen bigger in the platform, and that is using forecasting techniques, data science forecasting techniques. So what you see here is the last few months, 100 days, but we can query back, we can look back in history farther away. But what we do is we use data science techniques, time series. We forecast what is the expected range in the shaded area today. If our number of rows in this case is outside, like on this day here, we will probably alert you. If not, we will not alert you. It seems simple, and it's nice because we can take periodicities into account automatically. Data science, is able to do this. It seems simple, but it's very liberating. Not having to write lower and upper boundaries, not having to take into account periodicities manually, creating lots of rules in the process or complicated rules with SQL or Python it's nice. It does really allow for scalability. You can
Yeah.
do much more because you don't have to take care of these simpler use cases. Simple but powerful, because time series are not just useful for number of rows, but I'll show you later. You can also define your own KPIs or your key metrics, like we call them. And you can use this whole machinery of data science time series forecasting models to also use this on your own metrics, right? So again, try to make sure we make your users very quick in what they want to do.
Interesting.
And there's some more graphs people like to see. This is not very informative. There's some more information. You can also look into more detail. And I'm going very deep now because I think some of your users might be interested in data science, etc.
Mhm.
Right? So you can see lots of information about these machine learning models, different components making up the predictions, right? It seems like day of week is a very important periodicity. Overall trend also, and there's some other things like holiday spikes and day of month, right? But it's really nice that you can get confidence into predictions, and I can go even deeper if I want and go really deep. But basically, data science has you covered. If you want to, you can go very deep, but you don't really have to. You can just go here and see this one number here fast. That's almost always enough.
It's really cool. It takes away a lot of the kind of manual effort of having to write like SQL checks on row counts and stuff like that. And if you have multiple tables, you have to do a lot of these very basic checks. So if that takes a like that, if that's all automated, then the data engineers can focus on writing the actual transformation logic rather than writing a lot of the basic row count checks. So that's really cool. Yeah.
Yeah. And it's actually not so easy to write a check for this that works well and takes into account all the special days, etc.
You're gonna have to, if you want to do a time series, you might have to like query the previous version of the delta table and then do the row count comparison. It gets, yeah, you're gonna have to do some plumbing to get that working and all that. So yeah, the more automated, the better it is. So
Yeah.
that's really cool. So far, all of these are out of box, right? None of this is actually, someone going in and write business rules. All of these are out of box kind of checks that's provided by Anomalous,
Yeah,
correct?
that's correct.
Cool. So that's the 80% that we were talking about. And
Yeah.
in the event of people having very specific business rules that they want to set, or maybe industry specific rules they have to meet, then they go in and write those 20% of rule setting and say, this is my own rules in my business and my industry I have to meet, which is good. So then you again take away the 80% of the efforts. They only need to do 20% of the work. So yeah,
Yeah.
cool.
Precise. Exactly what I was going to say. So great. And let's talk a bit about this 20% as well, right? It's also important. So again, everything is automatic. We can talk about checks in detail, but let's not do that today. But basically, this is where these two other check categories come into play. One is validation rules. These are what you think they are, hard and fast rules that every record has to comply with the rule. If just one record doesn't do what the rule says, that's an error. That's a failure. And then we'll talk about that in a second. But we also have key metrics. And if you remember the time series, which I just spoke about, this is exactly the place where you can create your own time series, or you can create your own metrics to be analyzed using time series. And both have their uses, right? Sometimes you really have to be sure that certain thing never occurs. That's the domain of validation rules. But sometimes you're not really exactly sure. Like you might have some null values. Maybe it's 5%, maybe it's 5.7%. That's fine. If it's tomorrow 5.8, maybe that's also fine. But if it's going to be 7%, then you do want to be notified, right? But again, you don't want to have to figure out what's the limit, what's the threshold. And though you could do that, a very fruitful way of working is just using key metrics, because this will allow you to use the the anomalous machinery, the algorithms, and it's just your job to define the metric and our job to do all the rest. And in both cases, for validation rules and for key metrics, we offer a low code / no code interface. You mentioned a few times business rules, business logic. Yeah, exactly. Often people with business logic, business knowledge, or more on the business side of things, which means they might not be really much into the data engineering, SQL writing, or Python writing side of things. And rather than having to go into a pretty slow cycle of them telling you what they want and you telling them this is how it looks like, this is okay, right?
And
It's
something
better.
gets lost in the translation. Yeah.
It's the old DevOps world, when people wrote something and throw it over the fence, and 3 months later the ops people realize it cannot be operationalized. That is something to be avoided. Automation definitely helps there. And in our case, this automation or the help we provide is a low or no code interface. For example, we can go for very complicated examples, but as a simple one, if I just want to say, well, my certain column should never really be different. So I don't care about individual transaction values, but I want to know that on average, my transaction amount, the mean value, should not be certainly not the anomalous. So I can just go in, click, save and run, and go ahead, and it will work from the start. Um, that's very nice, and I'll show you how it looks like actually right now. Um, which one is it? This, right? So this gives you again like behind the scenes SQL code is written. So maybe I'll quickly show this. We do write the SQL code. In this case, it's pretty
Nice.
simple SQL code, right? I think most data engineers on the listen, hear this or see this would feel very comfortable writing this, but it can become very complicated very quickly. It can get very complicated. However, I didn't have to write anything. I'm just here and I see the dashboard and I see that I'm again using time series information and everything looks fine except for this final date today when we seem to have an error. We have way more, a way higher average than we expected. And that's probably not what we want. And that's the useful information again that we can bring back to our, to the people that own the table and say, hey, what's going on? If we find a root cause analysis, I was just looking for it. If we do find it, we will surface that as well, so we can help you fix it quicker. But in the end, it all boils down to having quick ways for people with domain knowledge to encode their knowledge into a check or a key metric. And we find it very valuable.
It's also the fact that requirement change over time, right? Again,
Oh
to
yeah.
avoid that throwing it over the fence and again, they can go in, use a no-code solution to set the changes of the rules is really important. Is that 95% predicted, is that settable or is that automatic?
That is configurable, yes.
Ah,
Um, Advanced is often the place where business people collaborate with the more technical folks, and you're definitely more technical. So you can set lots of stuff here. You can set the prediction confidence interval. There's always some tooltips which explain what it means. And by the way, there are many definitions, and our definition basically is directly related to alert fatigue. The lower you set this, the more common you will see notifications occurring, right? But we make it plain obvious. One useful thing is the direction, right? Do you care about going up and down, or maybe only about down, or something like this? And something very, very useful is you can in many checks you can also start grouping by time column. So sorry, yes, I'm jumping ahead of myself. I'll go back to that in seconds. But you can always add a where clause, right? You might
mhm.
only care about a certain SKU or certain, thing you want to, certain time range or certain something else. So
Interesting.
yes, there is always
Yeah.
there's room for SQL, right? And wherever it makes sense, we do definitely support that, right? In fact, I could even write a whole check in SQL. Like there's the option to use generic SQL code, um, which we find often very useful for people that have um, already existing checks in their own framework or somewhere cobbled together or some other platform. You can almost
So
always
you
just bring
can
them in,
lift and shift their
lift and
their
shift.
previous, yeah.
Well,
Nice.
our customer, I remember one of our customers, I remember now, did this big audit of all their rules they had made and all the stuff they'd created. And they realized, oh, 30% of my rules actually are just null checks. So we don't need to lift and shift. We can just live with automation there. So it's a nice thing. Yeah.
Nice.
And this goes really deep, right? I'm sure this is the simplest possible example, but you can imagine many customers use this to do advanced things, like, for example, comparing different tables or queries from different tables. They might be doing like migrations from some on-prem system to Databricks, very common use case. And they might want to know, like, hey, I know I don't have it's too expensive and too tedious to compare every single row that gets transferred. Or I might have two running systems at the same time, and I expect some differences because different in how things are stored, or maybe but I do want to make sure that in general, the patterns in my one system are similar to the patterns in my second system. So this whole machinery of using AI to check for patterns, etc., can also be used there. So I could really just go and, you know, select all the data from table one and select all the data from table two or some operation on this using SQL. And then I will
And
get access
see.
to the Yeah, to the AI based comparisons.
Nice. So basically, it's like validation checks for your migration, like success, right? Like run statistical summary, uh, for before and after migration, just to make sure that everything looks correct.
Except for the validation rules, which are these here.
Mhm.
Everything
Yep,
else is about time, right? It's about how things change over time, whether or not you have an explicit time column. That's because we use machine learning, and machine learning uses,
time
information
series.
about
Yeah.
batches. It's not just one record. It's really about how is my pattern today compared to my pattern yesterday. And that's why we by default, everything or most things in the tool are daily. So they run daily, and there's some orchestration behind the scenes to make it all work well. Again, one of the goals is to make it actionable, but also not to burden you and overburden you with alerts, right? So daily is useful for most, but we definitely allow for hourly stuff as well. So all checks here, the manual ones, the custom ones, can also be you can trigger them whenever you want. There's a cron option in there, and you can create hourly. Here it is,
Ah,
hourly rules. So they're similar to the other rules, but they're just hourly. Um, Not everything has like we only have a few options out of the box, but it's basically just the same, but more frequent. Yes, use cases are often streaming things when you batch them together and then you send it through an envelope.
yeah,
Yeah, but again, you could also resort to automation using your own pipelines and just use it through the code.
nice.
One more thing I want to notice quickly, helpful for when you have to look at the table at the table for the first time is the profiling report. Also out of the box, right? We can go in detail, but it basically just gives you an idea of the distributions of your data. And one thing I also want to note before we're out of time is that we've looked at things mostly from the point of view of the data user, consumer.
Mhm.
We've talked about like, being able to have information in Unity Catalog or being notified by Teams or Slack, right? Or from the point of view of the data quality owner, people that have the task of setting up rules or configuring a table and really are more into our platform. There's also a third user persona, which is governance or people stewards. People have a bit higher. They might not be responsible for one table, but for many tables. So
So they
having
want to see
aggregate
the
results.
data. Yeah, so they want to see the data quality metrics like dashboard, right? They want the reporting of how you did over certain pipelines, over certain tables, over a certain period of time, that
Yeah,
kind of things.
exactly, because that's their responsibility. We have two options here for
Nice.
you. One is built in, and it just shows a lot of numbers and statistics and time evolutions, right? How many tables do I have? How many are monitored, what's the quality, etc. Right? This gives you the information you need in most cases. You can do some filtering by table, by notification channel, etc. And it is definitely useful. And people like you can go and dive deep if you want. However, that being said, we see very often people creating dashboards in other places, right? In their own format, in their own existing dashboard. So what we do is we also are able to, I don't have an example, unfortunately, but we have a way of exporting all the check results automatically into a Delta table format. So very easily queryable, especially within Databricks, of course. Right. So this means you can actually consume in an aggregate manner. So on a higher level, you can consume all the results from your own existing Databricks dashboard, whatever. Yeah. So that's also something we see very useful.
Yeah, so then you can customize the dashboard if you need to, focus on certain traffic lighting system if you need to, that kind of things. Really, really
Yeah.
cool. Is there anything you can share with us on what's coming down the line?
But I can share one thing, which is private beta, which means that it exists already. That is actually super cool. You know better than me probably how much more like the quantity of data which is being generated that is not structured, that is not numbers or
Mhm.
strings, but really full-fledged
Text.
text or other unstructured things like pictures and videos and audio fragments. So this is our second product. We have Anomalo, which is we've been working on for 7 years. And we've started working, I think we started working 6 months ago or something like this, on applying the same kind of strategies to sort of automation first, low code, no code interfaces, nice UX, etc. Applying the same philosophy to unstructured data, starting with text. So we have already a few design partners. We have a working prototype. I can't show it, unfortunately, but if you are interested, or if you're, we actually are opening it up at some point in this year, I think. Maybe I don't quote me on this, but we definitely have people already working with this, and there are design partners, and they're having lots of praise for it because, if data quality is hard for structured data, imagine for unstructured data. And if you start making your LLM chatbots and your beautiful Gen AI applications, you're going to have to be way, way, way more confident about the quality of your data before. So behind the scenes, we do use Gen AI techniques, etc. But the structure is still the same as what you've seen. Like it's about notifying, detecting stuff, alerting the right way, making sure you can fix it, and it's all in a package which is easily consumable by people of different, skill sets.
The amount of Gen AI POCs, MVPs that's going on, if you have a viable data quality solution on top of unstructured text data, that would be absolutely amazing. If you're interested in Anomalo, in what Toon has shown today, or the Gen AI text, potentially private preview or secret private preview versions, reach out to Anomalo. I'm sure they'd be more than happy to help you implement data quality on top of Databricks. Thank you, Toon, for coming to Data Leaps and showing us such an amazing demo of Anomalo working with Databricks. I think you got a very, very sleek solution. I just love your UI. So congratulations. And thank you again for coming to the channel and enlighten us on Anomalo and its offering. Hopefully you come back in the future, maybe talk about the data quality on text data someday.
Yeah, that sounds great. Thanks for having me. I had a lot of fun. I hope to speak to you very soon. It was great to be on the show. Thanks.
Thank you. Thank you for watching Data Leaps. If you think the content is useful, please like and subscribe to the channel. I would really appreciate it.